peptide hormone. We have several peptide hormones. This might be a short example of imaginary peptide hormone floating around in your bloodstream. It's got this particular amino acid composition that's important, but really it's the sequence, the alanine following the glycine, preceding the glycine, all of that sequence, known as the primary structure of the protein, that determines how it acts biologically. It's the primary structure. We'll see that there are actually 4 levels of structure. This is just the first. Primary, it's often abbreviated with a superscript. Primary, secondary, tertiary, quaternary, increasing levels of structure. And we'll see. We'll work our way through these today.
So you're saying it determines the biological activity? Yeah, I mean, okay.
Okay, so
it's like...
Each one of these has their R groups on them, right?
So the way, and that's going to...
And that's going to determine how it folds up.
Okay.
And how it folds up determines how it acts biologically.
Okay, and that's what I always like. Okay, but that makes sense.
Okay, here's kind of a nutritional example you guys maybe can relate to. Here is NutraSweet, Equal. It's a sugar substitute. It's not a carbohydrate. It happens to be a dipeptide. Aspartic acid linked to phenylalanine. With aspartic acid N-terminal, phenylalanine C-terminal. It's a slightly modified one. The carboxyl group on the end has been methylated. But aside from that, it's just a simple dipeptide. That's really, really sweet, as you know. So sweet that they add starch and other stuff in the packet, because otherwise one serving of the sweetener would be like a grain in the corner. You might miss it, so you need a little carrier to flush it out of the packet with. Really, really sweet stuff.
And this is why it bypasses our glucose hydrolysis system?
Yeah, it's not a carbohydrate, it's a protein. Okay, but here's the thing about its primary sequence. This is its primary structure. Its sequence is aspartate phenylalanine. You can have a cousin of this that's made of equal amounts of phenylalanine and aspartic acid, just flip the other way. If you build phenylalanine aspartate, that dipeptide is not sweet at all. So the composition's the same, it's just the sequence, hence the primary structure has been flipped around, and it no longer works as a sweetener. That's almost a trivial example. In the world of proteins where you've got dozens, hundreds of these things, the sequence gets very, very complex into how it folds. Yes?
Would these break down?